I mean, I'll show you a few things about how these work, but mostly it's going to be just trying it out for yourself. So today's topic is called verifying trig identities. Verifying means to like confirm that something's true. So basically, I'm going to give you an equation not to solve for x. I'm going to give you an equation with two sides, some trig functions on one side, some trig functions on the other. And I'm going to say, hey, verify that, the left side is equal to the right side by kind of like substituting things in and out, changing things, combining like terms, that kind of stuff to change it. And so we want to basically show or demonstrate that, hey, this equation or this equivalency is in fact true. So here's one example. You can see I don't want you to solve this equation for x or anything. I'm just showing you, hey, all this stuff on the left should be equal to whatever's on the right. And we're going to try to prove that that is the case by using those identities that we've gone over yesterday that we summarized. And so this is called verifying. This is one of those skills where the process is much more important than the end product. Like I'm telling you the answer. I'm telling you that like everything on the left does in fact equal the thing on the right. Like I'm giving you the answer. You have to show me how to get there. This is all about the process, all about the steps you can take to do it. So let's look at the left side and let's see what we can do. And so you're just going to be trying different trig identities that we know to try to simplify it, to make it work out. First off, I see a cosine times a secant. Now that should stand out to me because what do you know is true about secant and cosecant? Those two, aren't they reciprocals of each other? Like cosine, isn't that 1 over secant and secant is 1 over cosine? So if I'm multiplying them, like let's rewrite this. Cosine of x times secant, isn't that just 1 over the cosine of x? Right? I'm allowed to do that, right? I can replace it with that reciprocal identity. I take one thing out, plug in something that's equal to. And if I do that, well, what is cosine times 1 over cosine? What would that equal? Just 1. They'd cancel out. Just like with the fraction. Remember when you multiply a fraction times its reciprocal, it cancels out into 1? That's the same idea with these trig identities. If you multiply any trig function times its reciprocal, they essentially cancel out and equal a 1. And this is why, because I've got a cosine on top, a cosine on the bottom. And so what I'm left with now is 1 plus 1 over the cotangent squared of x. Now, I'm not going to write the right side. That's the key thing with these verifying identities. I'm only going to start with one side and just stick with that one side. So don't think about like canceling things out and moving things to the other side. That's going to make it much messier, make it more difficult to understand. I basically am looking at this right side and saying, okay, that's my goal. That's my target. I need to try to rearrange stuff on one side to make it look like that right side, to make it look like a secant squared. So right now I have 1 plus 1 over cotangent squared. I need to make it look like secant squared. Well, do you remember what I said we should look at if I've got a squared trig function and adding or subtracting something, especially a 1? What kind of identities do you think this might involve? That's right, those Pythagorean identities. Remember the a squared plus b squared equals c squared? Do we have a Pythagorean identity with 1 plus and then something maybe with a cotangent? Oh, wait a minute, we don't have any trig identities with 1 over a function, do we? Can I rewrite that? What's another way of rewriting 1 over the cotangent? Yeah, what's the reciprocal of cotangent? Isn't that just tangent? Okay, so let's rewrite this as 1 plus tangent squared of x. That's still the same thing, right? I just substituted one equivalent thing out for the other by using an identity. So we have now 1 plus tangent squared. And if you have those Pythagorean identities in your notes real quick that you can reference, do you see something that looks like 1 plus tangent squared? We do. What's 1 plus tangent squared equal to? That's right. So this 1 plus tangent squared, I could just write that as secant squared of x. Now at this point, go back and look at the top. What was I trying to get to? What was my goal? My goal was to try to rewrite this whole left side as a secant squared. And now check it out. I've done that. I got the left side to look like the right side by simply applying these various trig identities. At first, this seems super duper tough. And like, how do you even know where to start? And it's just going to come from practice and using some of those key rules that I mentioned yesterday in our lesson. But do you see what the kind of purpose is of these, or do you see what we're going for working with one? I'm going to try one more with you, okay? And now I'll just let you practice. So go ahead and jot this one down. 1 over cosine squared equals tangent times secant times cosecant. Just go ahead and write that one down so you have an example to look at in your notes to help you out. Now for this one, I want to make one side look like the other side. Now notice that I was very specific and I didn't say try to make the left side look like the right. Because is there a lot of stuff to work with on the left side? Not a lot on the left. Is there a lot on the right I can work with? Yeah. So a unique thing about these verifying trig identities is you get to pick which side you want to work with, which side you want to start with, which side you want to try to make look like the other side. So in my opinion, I would say, look at all these trig functions on the right. I bet I can do some replacing or substitution. I can apply a bunch of identities to rearrange that and maybe make it look like that left side. So for this problem, I'm going to actually box up this right side and say, okay, leave that alone. That's my target. That's my goal. So you don't touch that side at all. And I'm looking at the right side. I'm saying, all right, I want to apply some identities to see how I can kind of make this look like a 1 over cosine squared. Any recommendations for what I should try to do first, do you think, with these three functions on the right? Yeah, remember one of my first recommendations yesterday is try writing everything in terms of sine and cosine. And that's a great idea, specifically because my target, identity or side on the left there has a cosine in it. So let's try to write all these other things in terms of cosine. So let's start with the tangent. How do I write tangent in terms of a sine and a cosine? Is it sine over cosine or cosine over sine? Yeah, you're right. I was just messing with you. Sine over cosine. So tangent is the same thing as the sine over the cosine. That's one of those two quotient identities. This is being multiplied by the secant. But how can I rewrite secant in terms of sine or cosine? Do you remember what secant's the reciprocal of? Is that 1 over cosine? You sure? Yeah, you switch that first letter, remember? So secant is 1 over cosine. What's cosecant then? Is that what I sound like? 1 over sine. Sure. So I've just rewritten those three in terms of sines and cosines. Now that I've done that, what can I do on that with these three different parts right here? Does anything happen? Anything combine or cancel out? All right, so we treat this as like one big fraction because it's all being multiplied. I can take anything in the numerator and cancel it with anything anywhere in the denominator. So I see a sine up top and a sine in the bottom. How about these two cosines? Do those cancel out? There's two of them. But they're both in the denominator, so they wouldn't cancel. Instead, they'd get multiplied together. They'd only cancel if it's division, like one up top and one on the bottom. So what I would do, let me write this below, is I'd say, okay, so in the numerator, I have a 1 because it's just 1 times 1. In the denominator, I have a cosine times another cosine. So we'd write that as cosine squared. And guess what? What was our goal? What was our target? 1 over cosine squared. What did we get? 1 over cosine squared. Are we done? Yeah, that was our goal, to try to make one side look like the other side. We have verified that this is a true equivalence. We've shown that, yeah, that right side is equal to that left side. They're the same thing. All right? Box up, be like, yes, I did it. Now, take a look at that worksheet I passed out. You're going to be doing the same thing. Oh, that's a typo. Yeah, that should be a cosine. And also my PDF printed funny. That's weird. I'll have to fix that. Oh no, they all did that. Yep. Yeah, this PDF did not print out well. I'll try to make a better one. Yeah, that should be a cosine. Sorry about that. But essentially, you take one side and you try to make it look like the other side. All right, apply identities. See what you can do. You can discuss this with each other, you know. Collaborate. I think that's very key for this. Have fun.